go back. Remember last summer when we talked about fractions with pattern blocks?
Yes.
Okay, the yes said it all. How comfortable are you, Ashley, with fractions with pattern blocks?
Better.
Okay. Well, we're going to work on that again today because I got the feeling that some of the people, and especially I got this feeling talking to the principals last week, that they weren't quite comfortable with that yet. So we're going to work on that again. We're going to add the Cuisenaire rods in there with it. So you have the two different models to compare. So I've got some new things. I'm going to start more basic than I did last summer. I think last summer one of the problems was I didn't start from the very beginning. I assumed, that I just assumed too much. You know how you do that sometimes. Anyway, so we're going to start really basic, so please don't think that don't let me bore you. I want you to think like a student, okay? So that you'll know what questions a student might ask, what misconceptions they may have, and how you can clarify those, all right? And please remember that I'm very, very old, and so if I don't like choral responses, so I will either use the sticks to call on you. If I know your name, I'll just call your name. Okay, so don't just shout out answers, because that's one of my ears I can't hear. I'm just like Rush Limbaugh, I can hear. Okay? Y'all know who Rush Limbaugh is? He can't hear. Okay, so we're talking about number sense and algebraic thinking this summer. Last summer was kind of geometry and algebraic thinking. There'll be some geometry thrown in again also, but mostly algebra and number sense. So just a little bit of the background. So the NCTM, so what does NCTM stand for, Melissa?
National Council of Teachers of Mathematics.
You read that very well. It is the national organization for mathematics, and they came out with their standards in 2002. They have since then come out with some books on, that say from research to practice, where they're, a lot of their books are very researchy, and so now they want them to put that into practice. So one of their things is that the students need to learn to value mathematics. And to me, that's important. You'll be getting this PowerPoint later, so you really don't have to write all this down. The paper is just for working the problems once we get there. Okay? So we want the kids to learn to value mathematics. I do not want to hear you say that students come up to you and say, I'm not good at math because my mother wasn't good at math. That won't work. They need to learn to value mathematics, and we want them to be confident. That is so important to me right there, this confidence in mathematics. Because sometimes children think, and sometimes adults think, that when they're given a problem, if they can't do it like that they must not be very good in math. Well, even people who are really, really good in math, like Einstein, did not solve problems like that. It takes thought. It takes thinking about, well, what if, and, what if we did this, and this was different, and maybe that would work, okay? So confidence that they can work through the problem, even though they don't get it in the first 5 seconds, okay? And we want them to be problem solvers, of course. You've been hearing that for years. And then the communication piece is important. Communication is so important. Yes, ma'am?
One thing that I do at the beginning of the year is I'll do a little video game and I'll have a kid come up and do the video game, and then when he dies, I'll say, game over, too bad, so sad, I guess we don't know how to do this. And they're like, wait, let me try it again. And I said, when you're playing a video game, you die over and over and over until you figure it out.
That's
and math is the same way. Oh, I don't know it, too bad, you don't do that. So I tell them it's the same as a video game.
That is perfect. So why can't they take that attitude into, the math class like that? Maybe that would be something the principals could use with the teachers, so the teachers didn't think that they weren't good at math, because sometimes, elementary teachers sometimes, like K1, 2, 3, they kind of focus on reading. They want to be reading teachers. That's their love. And so they even think that they're not good with math, when really they really are. Okay? And then they have to learn to reason. Thank you, Pam, for that wonderful idea. I'm sure Denise wrote it down.
I'm working on it.
Okay. Because remember, as a teacher, you are 3 things. You're still learning mathematics. I'm still learning mathematics every single day of my life. Well, not every single day. I didn't learn. Well, I did. The nurse took Christopher and I sailing, and so I learned a little bit of math about how to make that thing not hit me in the head when he was changing directions. I used to know the name of it, but I forget
The boom.
these. Thank you.
They call it the boom because
He taught me the name, but you know, once I left the boat, I forgot it. And you're learners of math, constantly. You're teachers of mathematics, and you're an agent of change. Now, what do you think I mean by you're an agent of change? And my glasses on so I can actually read these. Isabel, is she here?
You're gonna call me. Agent of change.
Yes, ma'am.
Helping students keep up with the changes.
You can phone a friend. Who do you want to phone? Okay, yes, ma'am.
Agents of change, as in you can change the perception of math. If you have students that don't like math, you can change that perception by giving them a view of math that they will enjoy and strive to get better at.
Very well said. So you can change their personal perception of how they do math. That's one change. What is another, Ashley?
Changing the perception of other teachers and administrators on how math should be taught. I was talking about earlier, spoke to a second grade teacher and said manipulatives, they're a little bit too old for that in second grade. I said, well, no, actually, we can use them all the way through high school. We did, with functions, did colorful tiles and complicated area perimeter and XY function with the tiles.
Yes, yes. So a second grader said they were, that is a wow. That is a wow. So that too is that collaborative, that PLC thing and the horizontal teaming that you need to do, and the principal. He's got to get involved, or she, with that and make sure that the teachers are doing that vertically, K through whatever grade is at your school, 5. Okay, so just a little bit about this. There's procedural understanding, which is what we all learned when we were in school. I'm old, so you know, I was taught procedures, I was taught to memorize, I never really was taught to understand. I never was taught it was important for me to understand why. Okay, luckily my mother was a math teacher, and I'm one of those that cannot learn something if I don't understand why and how it works. So my mother could tell me most things, why and how it worked. There was one thing she could not help me with, and that was with finding square roots. Remember, no calculators back then. So we learned 3 different ways to find square roots, none of which, well, I remember one because it involves averages, but I don't remember the other 2 whatsoever. I know one of them had a dot, and you mark off 2, and you mark off 2, I don't know why, and then you do something, but it's not division. Okay, so that's procedural understanding. Here's an idea that I know. I know to divide fractions, I flip and multiply. Here's an idea that I know. I know if you multiply 2 negatives, you get a positive. Okay, don't know why, but you do. Here's 3 ideas that I can put together. I know addition and subtraction are opposites of each other. Okay, so I have a new idea, and I'm going to connect it to this idea. That's procedural understanding. This is relational understanding. Look at all the connections there, so that when I have a new idea, I can connect it to a lot of things, and that makes a big difference. There's still some things I may not can connect it to yet, but hopefully, as I mature, I can connect it to those as I mature as a student. So, learning and cognition, you need to not put so much emphasis on procedures. By procedures, you know, the algorithms, okay? You need to facilitate flexibility. What does this mean? Use analogous problems. Pam, what does it mean?
Problems with many steps.
Problems with many steps. What else could it mean? Okay. No volunteers, so Patricia. Patricia not here?
Well, no, we have Patricia here.
Tricia's ready.
Patricia.
Teacher here.
Yeah.
Problems.
What does this mean? Use analogous problems.
I'm sorry, I don't know what analogous means.
Kim, you want to tell us?
So that was what you.
What was it? Yeah.
Remember, I cannot listen to more than one person at a time. Patricia,
Does it mean analogy?
well, that's the word, yes. Yes, ma'am?
They do the same function but different structures. So, for example, if I was doing a math problem, the math problem would do the same function, like the same thing, but they'll be different structures. I'm doing it in biology. Analogous structures are same function, different structure.
Because you're science.
Yeah.
So when you use the word function in science, it means something different than in math. So what does it mean in science?
Structure, analogous structure.
Can you give me an example?
So, analogous function. So for example, I have a shark fin. It swims. I have a dolphin fin. It swims. I have a penguin flipper. It swims. Their bone structure is different. They do not have the same bone structure.
Okay,
So that's why same function, different structure.
oh, I see. So the fins have the same function.
Yeah, they all swim.
Yes,
But their
but
bone structure is different.
it's different. Okay, that's very nice, very nice. Brandon,
That's what I'm saying.
you were gonna say something?
Yeah, I was taking something that a student does in everyday life and tying it into a math problem.
Okay.
Like analogy, she did earlier, the bottle of water,
Mhm.
that's I think was a liter gallon. They see those before.
Mhm.
I mean, use that to solve a math problem or
Okay.
an analogy. based
So
on something
take
they
something
see.
from their everyday life and show how it reply or how it, what's the word I'm looking for? Relates.
Relates.
to the math problem. And then strong representations. What do I mean by strong representations? Remember, we talk about representations all the time. Kim? I keep looking for you
Sorry.
back there because you sat back there last
I
time.
know, feel out of place right here. My friend,
Representation.
Pam,
Provide strong representations, I would assume would be like manipulative, something they can touch, feel.
Now, y'all didn't see it, but while Pam was beginning to speak, Kim held up the container of Cuisinart rods. That is a representation. You can use that to represent different things. That's the concrete representation. And then, of course, we want them to justify conclusions and to illustrate applications. Use technology, which we won't be using in here. Use it judiciously. Don't just use technology for using technology, okay? It's got to teach something when you're using technology. Accurate and clear explanations and model opportunities for metacognition. And what is metacognition? Pam.
thinking about thinking.
Thinking about thinking. Good. All right. So I'm going to skip this slide and go right to the activity. So we're going to talk about division. Okay. Now, if you're in elementary school and you start learning about division, how do you learn about that? What is the first thing your teacher is going to tell you? There's another Patricia, or is this the Patricia that's gone? Patricia Roca. She left, didn't she? Yeah. Allison. Alyssa.
Please, can you repeat the question? What's the first thing that we're,
If you're beginning to teach division to your students, they've never seen it before, how do you teach that?
thinking back to like the lower grades, I would assume you have a certain amount of objects and then you split or share, put those objects into a certain amount of groups evenly. So you distribute them into the groups.
Okay, so you group things. You take the set and you put them into groups depending on the problem, right? That's exactly right. So it's how many groups of a certain size are contained in a number. So if we have 12 divided by 3, 12 divided by 3, that means how many groups of 3 are in 12? How many groups of 3 are in 12? Is that the only thing that can mean, Jen?
No, that is not the only thing it can mean.
What else could it, let me go ahead and finish this slide. So we have 4 groups of 3. We can illustrate that, we can represent that. This would be a concrete. Pictorially, on the number line, do you see the 4 groups of 3 on the number line? It's pictorial representation. And then you would have the students write the sentence. There are 4 groups of 3 in 12. That's that communication piece. It's important for them to say. But this is not the only way we could understand that problem. So, Jen?
So you're asking in the first problem, how many groups of 3 can I make from 12? Another way to think about that problem may be to ask students, what would be in each, how many counters would be in each group if I made groups of counters?
Okay. So this one is asking how many in a group, or how many groups? Which one?
This one is asking how many groups.
Any.
I just rule and let you Coral respond. This is how many groups, and you can ask how many are in each group, which is the second way that that could be understood. So how many are in this group? If we have 3 groups.
There are 4 groups.
4 counters, and it's illustrated with the number line. And this is very basic. Remember, this is what grade? 3rd grade, maybe? Right. Trust me, we're gonna get more interesting. Yes, Ashley, thank you.
Whatever, I did this in 4th grade for division, and I started off, I told them I was having a birthday party, and I forgot to make the goodie bags, and each group had to make goodie bags
Nice.
for the party.
And you had some things for them.
I had things for, little toys and stuff to put in the goodie bags.
That's nice, very nice. So, this is for whole numbers. Does this also work with fractions? That's the question. I hear Ashley sigh. I heard it all the way up here. Does this also work with fractions? Are there 2 ways to think about it? How many groups or how many in each group? So, Candace, do you think this also works with fractions? Do we still have those 2 ways to think about it? How many groups can we make? Or how many are in each group?
I'm still trying to process that.
Okay. If you haven't taught elementary, like 3rd grade, then the number of group things is not fresh on your mind, okay? Because you just assume that, well, you just don't even think about that, it just comes natural, all right, so we have this. We have 12 divided by 5. That could mean how many groups of 5 are in 12? How many groups? Just like with the whole numbers. How many groups of 5 are in 12? Well, here's my representation with color tiles. I have 12 color tiles here. How many groups of 5 do you see? Hang on. I can't read this one, so I'll put it down, but I know it's the person back there who didn't show up. It's that other A name that didn't come.
Leslie, or, yeah,
That's in the board folder.
I know she goes by Leslie.
Oh, okay, so she goes by Leslie.
Yes.
So this one should be changed to Leslie, ladies, when y'all have time. All right, so, 2 groups of 5. You see them? Here's a group of 5, here's a group of 5. There's 2 remaining. So what do we do with that remainder when we're dealing with fractions? That's the question. What do we do with the remainder? Is it 2 out of 12 left? Is the answer 2 groups of 5 with 2 twelfths? Hang on, Brittany. Think about that for a while. Two and 2 twelfths. Sure? 2 and 2 twelfths. Brandon's saying no. Pam's thinking, but not gonna tell me right now. I tell you what, I'm gonna let you cheat on this one. I want you to actually divide this out. Divide 5 into 12. Tell me what you get for your answer. We're in fractions, not decimals. Don't use your phone. Fractions, not decimals. I know you're
Oh, you
silent.
want fractions?
Fractions, not decimals.
Maybe when you divide, you get that.
If I divide it out, I get decimals.
You don't have to get decimals when you divide, Brenda.
So 2 and 4/10.
I don't want a decimal, I want a fraction, common fraction. A common fraction, not a decimal fraction, common fraction. Amanda? Yes.
2 and 2/5.
2 and 2/5. She said this, she got 2 and 2/5. When you divided, Pam, did you get 2 and 2/5? No? Did you divide 5 into 12?
Yeah.
you wanna come up here and divide it for us, please? Ma'am?
What'd you say again?
2
and 2/5.
2 and 2/5.
Okay, so she has divided, she got the 2. What do you do with that remainder when we're in fractions, common fractions?
That's your numerator.
Over?
Over your denominator. Oh, I got
Or
that.
4/10 is equivalent to.
But I want a common fraction, not a decimal fraction. I mean, all right.
Okay, but that's not very interesting.
You just taught me something.
This is a common fraction,
It's common
because it's not a decimal.
But say 4/10.
Justify it.
10 is nowhere in here except that. So I needed what a kid would do when you divide. Alright?
You're thinking equivalent fraction, but how would you come up with that?
Because I would have kept dividing. I would have kept dividing, bring down a 0, 520.4 times, which is equivalent to 4/10.
But when you put in that 0, you have to add a decimal, and she didn't want the decimal.
Yes, but isn't 4/10 as a fraction the same?
Yeah,
Same thing
yes.
as 2/5.
Yes, but
Okay.
when a student, and you're a student, not an adult, okay? When you're a student and you're teaching them to divide this, you are taught to bring the remainder up over the divisor. Because you want to speak before you So,
2 out of 5.
Jen,
Because you are trying to make groups of 5, but you have 2 left of a group of 5.
I just got the picture of it.
Did you?
Yes.
may I
That
draw
makes
it,
sense.
ma'am? Ma'am?
May I draw it?
Of course, please do.
Well, and don't they learn this concept in 3rd grade and decimals aren't introduced until 4th grade, so they wouldn't know to add the 0. What grade level?
I don't know what grade level we're thinking of
3rd or
right
4th.
now. Yeah, 3rd or 4th. Pretty soon we'll get to 6th and 7th.
Maybe just one more, just in case. I've used a lot of graph paper, so I have 12. 1, 2, 3. No, I don't want to do that.
Random.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 1 hole and that's a hole. 2.
I can see.
2 and 2/5. Now, thank you, Ashley. I'm not real sure if the student would know to draw these in groups of 5 unless the teacher had been working with them prior to this and they had been shown that. Pam?
And technically, I'm thinking if a student knew to write 2 out of 5, they would have written 5 out of 5 for the first one.
Right,
5 out of 5
exactly,
for the
you're
second
right,
one,
you're
and
right.
2 out of 5.
They could have.
Right.
Yes, and most students would, I think. So, at any rate, back to what Jen was saying, we have 2 whole groups of 5, and we have 2 out of 5 of another group of 5. And that language is what confuses the students. Even in here, we were confused a bit, right? Especially when I had this up here. You know how many of you looked at me and nodded? I mean, you just nodded because you have 2 out of 12 left, right? So it's 2 and 2/12. Automatically. But that's not what we're talking about. We're talking about groups of 5. Groups of 5. Okay? So, this up here is correct, 2 and 2/5. Right? Alright. So that's how many groups. And we'll get to how many in each group in a minute. I want to talk about models for fractions. There's 3 ways you can model fractions. You can use the area model. I forget we have a little pointer here. You can use the area model, which can be pattern blocks, which we're going to use today. color tiles. Okay. You can use a linear model, which could be Cuisenaire rods. I got this from the internet, so they're small. Cuisenaire rods. A number line with Cuisenaire rods with it, which is great, or just a number line. Okay? Or you can use a set model. The set model, does that look familiar? Does that look like a star item? You have to be careful with the set model. Students cannot or should not be expected to use the set model until they have conservation of number. Conservation of number. So what is conservation of number? Amanda.
I would say that they understand how numbers go together, like how numbers interact. So if I'm looking at 2/3, then I would have to know that I have 3 groups, and then I could sort based on that.
That's pretty close, but not quite exactly. Conservation of number, if you have early childhood people and you put out 5 pennies and they're close together and the student counts 1-to-1 correspondence using their little fingers and they count to 5, there's 5. But then if you spread those 5 pennies out and you ask the student, do they have more or less or the same, even though you know it's the very same, they will say more. Why do they say more? What are they looking at, Jen?
The amount of space, the area that
They're looking at that area and it appears to be more. So conservation of number means that they know no matter how far apart they're spread or close together, it's the same number of items. Okay, same number of items, right? So, you ever heard this? I didn't hear that until I had been teaching like 5, 6, 7 years. I was never taught that little poem. This is a pneumatic thing to help them remember how to divide fractions. And I was never taught that. I was just told to invert and multiply. Okay? Can you explain why it works? Raise your hand if you can explain why it works. 1.5 hands, not counting mine.
After we do this, I'll go over
Can you explain why when you divide fractions, you take the reciprocal of the second number and multiply? You can tell me why? Don't tell me why, just you can tell me why. So 2.5 now think that they can explain why. 3.5. All right. Well, we're gonna work on this today, okay? So look at this division. And we're talking about how many in each group, all right? So we have 5 divided by 3 means how many are in 3 groups if there are 5 total. Is that what that means? Better not work it out with the algorithm right now, okay? We're thinking. How many are in 3 groups if there are 5 total? 5 total cubes.
There should be how many groups?
This is not a how many groups, it's how many in each group. There's 2 ways to think about it, remember?
Oh, okay. How many fives are in 3 groups?
Is it how many 5s are in 3 groups?
How many are in groups?
How many 5s are in 3 groups? Does that verbiage make sense to you? No. Why not? I'll call on something. Why not, Brandon?
Now, you asked that question, how many 5s are in 3 groups?
Yeah.
But that's impossible to do that because I only have a total of 5. So
Okay.
I cannot have any group that only consists of 5 pieces to have a group of 5. I will get a whole group.
Okay. All right. So I'm sure y'all were listening to what he said, so Ashley D is, are you D or B?
D.
You're D. So can you revoice what he said?
Well, from what I was hearing, you can't, if there are 5 total, and you're gonna divide it up into 3 groups, you can't put 5 in one group, how many 5s in 3 groups? Cause that would just, if you say how many 5s are in 3 groups, that sounds like a multiplication. If I have 3 groups and there's 5 in each group, it would be 15, but actually this says there are 5 total. So they just don't mean the same thing.
So could the way we say things and what division actually means be why kids are very confused most of the time? How many in here are very confused? How many of y'all are science? Yeah. So how many science people are very confused? Okay, put your hands down. How many math people are very confused? Be honest.
Yeah, be honest,
Actually, I'm having nightmares because when I student taught,
Yeah.
this was in 3rd grade, and I massacred, jacked up their division. Cause when you put the 3 groups of, you had 12 and you broke it up into groups of 3, I was breaking it up into 4 groups, and then I totally switched it around, and then when I started to panic, I couldn't figure out what I was doing wrong, so it was a big fail. But
Yeah,
anyway.
it is very difficult to teach conceptually. It's much easier to say, Pam, come up here and divide this for me. Y'all got it? Okay, let's go on. Right? Much easier. Very hard to explain conceptually. So let's go on. We have 1 group, excuse the plural there because it's not appropriate, of 3 with 2 remaining. Is that what that meant?
That's it.
Not based on your, the way that you word it.
Not worded correctly?
Correct answer, but not based on the way you word it.
So, raise your hand if you agree with this from that. 3 people. Okay, Rochelle, tell me why you agree with this.
Well, we know there's 2 ways you can either do it by groups or number of items in the group.
Right.
So when you say how many are in 3 groups, well, I made a group of 3, which makes 1 group of, well, I guess that's 1 group of 3 with 2 pieces remaining, since 2 cannot make a complete group of 3.
Okay, Melissa, does that make sense to you with what Rochelle said? It doesn't have to. This is confusing.
I didn't,
The fraction.
to me, I think that makes more sense. 1 group of 3 with 2 remaining, that makes sense to me. But not from the example, does that make sense to you?
Okay. So,
Because when I looked at the example, I drew, okay, well, it says, are in 3 groups, so I do 3 circles, and then I have 5 total that I gotta divide into those 3 groups. I'm like, nobody wants to be alone. And then I'm like, 2.5, that does not make sense to me very well.
okay, there was a hand over here, Amanda.
Well, cause you didn't say what to do with the remainder. Do
Okay.
you want the remainder in 2 of the 3 groups, so then you have 2 groups with 2 in it and 1 group with 1 in it?
So where does the 3 come in your example?
Well, I have 3 circles.
Okay,
So like in my mind, I put tags on it. So like I was thinking dogs and dog houses.
Okay.
So I have 3 dog houses. I have 5 dogs. So either 3 dogs have a dog house and 2 are left out in the cold, or there's 2 dog houses with 2 dogs in it, which is what I did on my model, and then 1 dog house with 1 dog.
so that would be how many are in each group? Or how many groups?
Cause I don't know what you want. Well, there are 3 groups, cause that says 3 groups. So
Okay.
the 3 groups doesn't change. It's just what do you want to do with the remainder?
What do you want?
Do you want them to find a place within the 3 groups? Or do you want them to be isolated?
What do you want?
Well, I like them together.
Meaning,
2 dogs and 1 dog house.
2 dogs in 1 dog house, 2 dogs in another dog house, and 1 dog in another dog house?
He's mean to the other ones.
You know, math or something? Would that represent this
because I see one group of 5.
Yeah.
And then I don't see where the 3 groups come in, because I only see a group of 5 with ones individually.
Okay.
So, I mean, I see one group of 3 within 5, but I don't see how we make it into 3 groups.
3 groups, Pam, you wanna get that?
I'm still, Brandon and I were talking, isn't it totally worded incorrectly though?
Yes.
Because 5 over 3 means 5 broken into 3 groups.
Does it every time? It can. It can mean 5 broken into 3 groups.
5 divided into 3.
3 divided into 5.
5 divided by 3.
5 divided by 3.
Three's your divisor.
3 is your divider. Michelle?
Okay, just kind of came out with which is, well, how many are in 3 groups? So on, with the, model there that's in red, why can't one block be in one group?
So here are the 3 groups,
It doesn't say groups of 3, it says how many are in 3 groups.
correct?
So, one block is one group, the second red block is the second group, and the third block is the third group.
So there's 1 in each of the 3 groups.
Yes, which
And
is,
then you have this remainder. Does that
so
make
that's
sense?
how it applies to the statement up top.
How many in each group?
Yes.
You agree?
Doesn't say, it didn't say on how many groups to put in.
I think,
How many in each group?
I think the visual that has me also is that there's like no space, so they're all
Yeah.
connected, so my brain, then that's a group.
Thinking it's.
So if there was a space in between each one of those reference, okay, then they're different groups.
Okay,
I think the visual.
yeah.
So there's one group of 3, but we have 5. So there's 5 in one group of 3.
There is one group of 3, but that wasn't the question. The question was, how many are in each group? That's,
So
or just
one.
the other one, yes.
Okay.
1 in each group. Okay? Brendan?
I just comment on what Melissa said, that the visual does, because
Yeah.
whenever you said the 2/12 and everyone went,
Yeah,
because it looked like one giant group of
Exactly.
12 with 2 left
right,
over.
exactly.
Whereas whenever Ashley went and made a different visual, everyone's like, oh yeah,
Yeah.
2/5.
So, yeah, you're right. Not the best visual, so you had to be judicious in what you use. What would be better?
Probably the next thing that's gonna come up on your phone.
One time.
No, it's more confusing than that. Single connecting cubes?
So what's the answer?
It also depends on the tag, because like if I'm using cookies, I can break a cookie apart.
No, we just
No,
don't,
You're just using wholes.
for right now.
Okay.
Yeah, right. Pretty soon we're gonna break those cookies. Okay. So, let's go to this one.
That is 0?
That's a 0. 0 groups of 5. We have 0 groups of 5.
Yeah, see that? There's no 5 blocks.
No groups of 5.
We have 3 parts of 5.
Yes.
Is this tied to the
On
first
left-hand
one?
side. That's
3
3 out of
parts.
5.
What part of 5 is represented 3 of?
Then why isn't it not shown like the other one? Like that there's 5 total.
Because the person that made it just didn't do that,
Well, that just that picture doesn't look like it's out of 5.
which would be me.
So is it supposed to have the 2 blocks?
Okay, for Rochelle, those 2 blocks are there, you just can't see them. Okay. I don't know if I even put them there. Well, let's go on, because let's see if we can make sense out of all of this. And we're still dealing with just whole numbers, right? So far. And the 2 kinds of division, how many groups? How many in each group? Which is extremely confusing to kids. Okay? So, and adults, and big. So, the language is important. I keep forgetting we have this. If we say 1 divided by 1/3, some students are confused. What does 1 divided by 1/3 really mean? thinking about what we just talked about, Jen.
Means how many groups of 1/3 can I make with one?
Okay. How many 1/3 are in one? So is that a how many in each group or how many groups? Okay, I heard a choral response, how many groups? That was only like 4 people, right? So, let's see. Brianna, where are you, baby?
Can you say that again?
So is this how many in each group or how many groups?
I'm still trying to process this.
That's okay. You want to talk to somebody about, talk with your neighbors about this, and then I'll come back with you, okay? Is it how many in each group, or how many groups? 3.
And how many 1/3 can you?
So then it would be how many? How many 1/3 groups? So you're getting 3 groups and then where is
There are
3 groups? So that's how many.
There are 3 groups containing 1/3 in each group, which equals 1 total.
And I wanna do a comparison, how many thirds I got? Ooh, sorry.
So there are.
Okay, you got about 3 seconds.
Because this is the 3 change the number and then it's 12 divided by 3.
That's a third, 1/3,
So, okay,
1/3,
so
1/3. Okay, one more? No? How many?
In each group there is one.
That's what it is. Still just in the last first. Then I had all my notes. And I had my stats, that's pretty short. I was talking to Amy Sykes. I just said it.
How many groups?
Not the graphic. The stack. And out, it's for another sheet. And out.
I remember last time I talked
If we can come back together.
We did that with them. We had them use painters.
Okay, so how many groups of 3?
Okay, I just want to make a comment. As I was watching you, do you know how many of you grabbed manipulatives to try to illustrate this? And you're an adult, you can think abstractly. So how many times do kids need these manipulatives to help them work through a problem, even if they're in the 2nd grade, 3rd grade, 4th grade, 5th grade, adult level, right? Some of you use the manipulatives. I see tiles over here. I saw Cuisenaire rods used several times, and some of you drew pictures, a pictorial representation. But very few of you tried to do it completely abstractly. Okay? All right, so we need an answer, and I actually drew, So you wanna, you drew a picture.
Yes.
Would you like to share your picture?
And I always told my students when I started, so when you're in the STAR test, I guess that's not all about the test, but graph paper, we started day one with graph paper. But, so I have one,
When she said graph paper, she really just means grid paper, the axes
Oh.
are not on it.
that's right,
So
yes, grid
just a
paper.
grid, yeah.
And,
Kept students organized.
divided by 1/3, so I'm gonna make my one, and I'm gonna divide it into thirds. Okay, how many 1/3s can I make out of one? Divide it, break it apart into thirds. So, 1, 2, 3, and that's 1, so 1, 2, 3.
So 1 divided by 1/3 is how many, Ashley?
3.
Is 3.
I can get 3 1/3s out of one.
3 1/3 out of 1. Okay, how many of you in your head actually inverted the 1/3 and multiplied and cheated? Anybody? Good, I'm so proud of you. I did. Okay, it's very tempting, just in your head, flip it and cancel, right? So you agree?
It's the wording, excuse me, the wording is, there are 3 1/3s in one, as opposed to there are 3 groups of.
And the wording is
Yes.
important. So how do you think the state of Texas writes it on the exams?
As confusing as possible.
Right. Well, they don't intend for it to be, really, they don't intend to confuse people. But they do use the correct mathematical language, which sometimes teachers don't. So, yes, ma'am. Ashley, you want to read this correctly?
Okay. Maybe I would say, I don't know.
Divide 1 by 1/5.